Here's a fun little question about statistics. A food vendor developed a new sandwich type for sale. The vendor made estimates about the sales of the new sandwich type over time. A linear regression was used to develop a model for the sales over time. The figure shows a graph of the residuals of the linear regression. Which of the following statements about the regression is true? Okay, so we have this regression here. We have the residuals, which is how far we are away from our prediction. And when I say how far, positive or negative. And answer choice A says the linear model is not appropriate because there's a clear pattern in the graph of residuals. So there is a clear pattern. If I look at the graph of residuals, I can clearly see that it starts below, moves above, and then comes back down below in what looks like a quadratic manner. So A is a strong contender. Let's read the other answer choices to make sure it's the best. B, the linear model is not appropriate because the graph of the residuals has more points above 0 than below 0. And it looks like, yeah, there's one more point above 0 than below 0, but the points below 0 are farther below 0. So this looks like it would be the best fit line that a piece of technology would give me, even if it might not be appropriate. The linear model is appropriate because there's a clear pattern in the graph of the residuals. So if the graph of residuals was itself linear, then linear might make sense, but we have a problem here. And the linear model is appropriate because the positive residual farthest from 0 and the negative farthest from 0 are the same distance. That's not necessarily the right thing to think of. You should see the sum of the residuals canceling out because I want them to be sort of this middle. The way that the sum of squares works would get those to add up to 0. But my choice is A. And as a better description of this, if I have something like this, that came from, let's say, maybe a piece of graph. So let's say this is my best fit line, and I would see something like this. And if you start looking at this, you can see like this distance here is this distance here. This distance here is this distance here. So the fact that we see a pattern going on here that looks quadratic should lead me to think that perhaps a quadratic model as opposed to a linear model would be a better one, because this would translate into a quadratic structure pattern in the original data. So the answer is A.